Welcome to this beginner-friendly tutorial on creating powerful C# custom tools in Unity, designed to significantly enhance your development workflow by automating repetitive tasks and adding specialized functionalities. Custom tools are scripts that extend Unity's editor capabilities, automating repetitive tasks like mass object renaming and introducing new features to optimize your workflow, making development more efficient. A properly configured development environment is crucial, starting with Unity 2021 or later and Visual Studio Code for writing and debugging C# scripts, offering superior syntax highlighting and IntelliSense. Ensure you have the Unity extension for VS Code, which provides debugging support, and the Visual Studio Editor package, version 2.0.20 or higher, updated in Unity's Package Manager for seamless integration. Finally, set VS Code as your external script editor in Unity Preferences to integrate your development environment seamlessly, allowing for quick script editing and debugging directly from Unity. To begin creating an editor script, first create a new folder named Editor within your Unity Projects Assets folder. This special folder tells Unity these scripts are for editor time use only. Editor scripts, placed in this designated folder, are distinct from regular C# scripts and are specifically excluded from the final game build, ensuring they don't impact game performance or size. Create a new C# script inside the editor folder, for example, named mycustomtool.cs, following standard naming conventions for clarity and organization within your project. Your custom tool script needs to extend the editor window class, which provides the base functionality for a custom editor window, and include the Unity Editor namespace for editor-specific APIs. Initialize your window using a static init function with a menu item attribute, like menu item, to add your tool to the Unity toolbar for easy access. The onGUI function is where you render the editor window's user interface using Editor GUI Layout for automatic layout and GUI Layout for more manual control, allowing you to design interactive elements. Level editors enable direct creation and modification of game levels within Unity, often involving custom inspectors for scene object manipulation, such as placing environmental assets or defining gameplay zones. To create a custom inspector, first create a C# script, like mycomponent.cs, to attach to a game object for holding data that your custom inspector will then display and modify. Next, create another script, mycomponenteditor.cs, in your editor folder, extending editor and using the custom editor attribute to link it to your mycomponent script. Override the onInspectorGUI method to add custom UI elements and functionality to your inspector, such as specialized buttons, sliders, or custom data visualizations tailored to your component. You can access the target component, which is the instance of myComponent being inspected, using the target property and cast it to the appropriate type to interact with its data. Remember to call drawDefaultInspector to include all default inspector elements below your custom additions, ensuring that standard properties are still visible and editable alongside your custom UI. Custom inspectors can directly manipulate scene objects using the Handles class for drawing 3D gizmos and the onSceneGUI method for interactive elements like custom movement handles or selection tools. Asset processors automate tasks during asset import by using the Asset PostProcessor class to hook into Unity's import pipeline, allowing you to intercept and modify assets before they are fully imported. To create an asset processor, make a C# script like myassetprocessor.cs in your editor folder and extend Asset PostProcessor, ensuring Unity recognizes it as an asset processing script. Implement onPreProcess texture to modify texture import settings via Texture Importer before the texture is imported, for example, automatically setting textures to sprite type or adjusting compression. You can also implement onPostProcessModel to modify the imported game object after a model has been imported, allowing you to add components, adjust materials, or reconfigure its hierarchy. Asset processors can automate texture type, compression settings, and even validate texture sizes, ensuring consistency across your project and reducing manual configuration for every asset. Utility windows are custom editor windows that add new functionalities, manage project settings, or perform specialized tasks, such as batch processing assets or generating complex scene configurations. To create a utility window, make a C-sharp script in your editor, folder, and extend editor window, which provides the necessary framework for creating a standalone, dockable window within the Unity editor. Use the menu item attribute and a static show window function to make your utility window accessible from the Unity toolbar, typically under the Window menu, with a custom path like window/myutilityWindow. Implement the onGUI function to create the user interface using Editor GUILayout and GUILayout elements, allowing you to add buttons, text fields, toggles, and other interactive controls. Utility windows can modify object properties, create assets, and automate complex workflows, such as generating a series of prefabs based on user input or performing project-wide data validation. You can access selected scene objects using selection.gameObjects to get an array of currently selected game objects and modify their properties via transform and get component for batch operations. By mastering these powerful techniques, you can create highly effective C-sharp custom tools in Unity, significantly streamlining development, enhancing productivity, and tailoring the editor to your project's unique needs.